who makes sure that I'm recorded. Okay. So today I thought we would just talk about like whatever you wanted to talk about, but I was going to give you some options, okay? I could talk about what the latest on Azure AI, but Marion did such a good job that I would ruin it, right? That was beautiful. Like I was like, wow, I should do that demo because that's amazing. She showed AutoML, she showed the new workspace, she showed the new data sets concepts. And it's and all of it, like it's a that was a I was messaging Cassie, I'm like, this is really good. My presentation's gonna suck. I think that's what I said, right, in the Slack? Okay. Okay. So these are our options, and we can do any of them. But I've found that like a lot of the demos that we talk about, like stuff happens and you're like, hey, that was AI, and then you have no idea what's going on. So I can talk about like how it works, like literally exactly how it works, and do that. Or I could show you what's in Azure Machine Learning Service. I can do like a tour around the workspace, what's in there and how it works, but I won't tell you what it's doing because that's the machine learning bits. I could talk about ethics and AI. We have for that. Or I can talk about whatever you want. So what I'm going to do is I'm going to give you all a minute to think. And by the way, as we go, because sometimes people don't like asking questions because there's other people, you know, you don't want to sound dumb. Because there's no such thing as a dumb question. There's only dumb people. So what you want to do is you want to go to aka.ms, and if you type something in that box, it will go right to my phone. And it will ding me. And I won't even know who it is. There's no names. So no weird things, okay? Because if it's super weird, I'll just stop and we'll read it all. And so what happens is during like any good breaks, I'll just go in there and be like, all right, what did people say? So who's the first one that's going to try it? So to make sure that it works. Because I wrote the code for that crap and it may not work. So you put something in and you should hear my phone ding. And then I want to hear a lot of dings. Or just raise your hand, okay? So I'm going to give you do you just do these things till time runs out? There you go. See, it works. Good job. Do you want all these things till time runs out? Is there one that you want me to pay special attention to? Would you like me to do something else? It's all for you. The only reason I'm here is for whatever you want, okay? And if something doesn't make sense, that's my fault because I'm a bad teacher. And then I can rephrase, okay? So I'll give you 60 seconds to think about where you would like me to start, and you can put it in the box. By the way, I turn that off after sessions, so don't be like middle of the night like, yeah, I know it's 2 o'clock, but for Seth, it's like 1 a.m. where he lives. Don't do that crap. So a minute, and I'll warn you that when I ask questions, like I would love to hear answers from you all, and I used to teach like high school in the US, and so awkward silence is basically only awkward for you. Doesn't bother me one bit. All right, so let's see what people are saying to me here. I'm going to put this down. 10. So it works. I didn't write it. It was Microsoft Flow. Beer. All right. What's new? Okay. All the topics. And then I have a talk, ethics and GDPR. How does it work? What does Azure do with cybersecurity and ethics? How does it work? Do you have standard data sets, for example, weather? So the answer to the standard data sets is we do. Where is it? What's it called?
Visual interface or standard data. Oh, is that what you're talking about, or MS Open Data?
We have, well, see, we have all things. So she.
Actually, there's two different. I can't remember the name of the second link, but I can get it to you. And then the other one's MS Open Data. And then there's also, if you're using Old Studio, you use that. There's a bunch of data sets you can use to start playing around in there as well.
Yeah. So, by the way, this is my colleague Cassie. She's with me, and I'm with her, and we're the same team. So, she knows basically everything that I know, but probably says things better sometimes. So there is that. Okay, so we have ethics. How does it work? Standard ethics and AI, foundational. Azure Machine Learning, what's new? All agenda. How does Azure ML perform with really, really big data sets? Well, it turns out that it doesn't matter how big it is because you can load terabytes of stuff into blob storage and mount it onto the experiments as if it was a hard drive. and it will just read off it. So I think well. Can you share how you did this? Make this aka.ms? Yeah, it was Microsoft and Microsoft Flow take. That's it. You thought it was better than that. What's new? So okay, so I'm getting a good smattering of like this and this. Okay, and then for this one, I can show you something. Mernouche, who works on it, we did an Azure, there's a show that I do called the AI show, where we do one that's not out yet, and I took out all the best bits where I'm not talking, and I'm going to show you that. It's 8 minutes long if we have time, because it's super cool. This is crazy cool. So I'll just go in order. Looks like everyone decided, where did I do? Here's my clicker. So if you're like, I already know this, just be like this, and I'll just move on as fast as I can. But for some people, sometimes I feel like they show up to machine learning groups, and it's like, I feel like everyone has this secret knowledge. In reality, no one has it at all. Everyone's like, do you know? Do you? And so, the secret knowledge out of this. It was better the other day. Okay. A big flow to build. Basically, that people do is the Minimax and those kinds of tree search algorithms that prune the space. So the search space is infinite. Look at a problem and you look at the complexity of it. If the search space is finite, you might not need machine learning. So you think about that. Example I gave earlier today. And finally, you have deep learning. Machine learning, you have something called decision trees, which makes like an. Now, that's machine learning. But works in machine learning and deep learning really depends on your marketing guy. Have to be before they're deep learning. I guess it's a question for how deep does it have to be deep learning? We don't know. Depends on your marketing guy. Earlier, so if you heard it, I'm sorry, but imagine you work at a bank. Anyone work at a bank? There's like 2 people every time. There they are. There they are. Sorry, first of all. Programmers that work our banks are like janitors of computer science. Thank you. You work at a bank, and one day Steve, the marketing guy, comes. I have a really good idea. And whenever the marketing guy Steve has a good idea for a programmer, what do we say to Steve? Sure. Steve. I don't know when people put their checks to our type. I know this is like an old story because now it all sees the checks for you. Do you even use checks in this country anymore? Are we like cavemen in the United States? Basically, this story is from 1952. This is terrible. Slide has. Imagine still uses paper checks because it's 1992, right? And what Steve said is like, look, if you could write an algorithm to tell me whether the check is upside down, that would be legit. Could you do that? Well, let's pretend your bank is really crappy. Well, all banks are really crappy. And write this as a programmer? Right? This image. I can do it, but it's going to take 6 hours. It's really going to take one, but there's a lot of YouTube to watch. Right? There's a lot of YouTube out there that, and how who's going to watch all of it? Have to. So you write live, right? And then things that we programmers do when we're trying to get stuff done. You know what I'm saying. All of you know. Maybe shut the door. There might be bosses here, right? Are people looking? And then Steve comes back 6 hours. This is glorious. So Steve was the CEO of the company. Mary owns the bank, and she's like, "It. Can we just do one thing?" And then Steve comes and is like, "Hey, this one." Anytime the marketing guy Steve says, "Can we do this one thing?" it's a terrifying thing because we have no idea what they're going to say. They're going to think it's easy. It's just one button. Have you ever had them say that to you? Just one button. Just launches SpaceX into the moon. And, one button. Wouldn't be a bank CEO. To be a bank CEO, is that how it's here too? Picture of her horse on her text. Check picture, right? Now you're a programmer. Can you do this? Yeah. Of her stupid horse, stupid because obviously she's the CEO and her horses. So they give you the picture, and what do you do with it? Well, you're a programmer, right? You're going to go through and be like, well, it's darker here and darker there. Write a lot of if statements and for loops, and that's going to be code that you action somewhere. You did that. Take an exclamation because you had to write that crap, right? And you did it, but you did it. Right? It's going to take 4 hours. No, there's a lot of YouTube to watch. Right? So then Steve comes in and have a really awesome idea. Right? Notice that the complexity went from not too bad to it's kind of bad, but I can still do it. Steve comes down and says, you know, for every person, for every picture, for every. Do you see how your programmer brain just exploded? Did you feel that? You felt it, right? That gap is huge. That gap is where machine learning works the best. Okay, think about it. You've all written code where you've had to add an if statement, every other week, and you've had to change the number from 0.5 to 0.7, and it somehow kind of worked. When you smell or machine learning, okay? That's when you use it. And that's the best way that I understand how to use it. Okay? That's how I do it. When you program it, complex. Okay? So, think. Okay. Machine learning. It just makes functions. These are called models. This is a function. I'm going to show them. I'm going to open them up. And there's not going to be butterfly out or saving some things, like everyone says. It's basically a way to serialize a function in a different way. It's actually a lazy way. And has to watch. What did build a model? And everyone was like, okay, you saw all these models being built. They were great. By the way, that tool he ran, you know that figure out which model to use in ML.NET, it's actually automated machine learning. It's the same algorithm. If you use Azure Learning Studio, the old one, called TLC, ML.NET is. I don't know if you knew that, but I want to just fill that in for you. TLC, sometimes it shows. And now all of a sudden you're looking at this, you're like, well, this doesn't look so difficult. But then some questions you have, right? For example, what is the magic and how does it work? Algorithms to giving the computer data and then it figures out the algorithm itself. That's what it does. That's machine learning. You all knew this. And if you did know this, it helps you when the gap is useful for machine learning. I think I read in CM like 40% of companies have AI in their title don't even use it. So they just, all you need to say is like AI and then like blockchain and you're totally get all sorts of VC. Always have to start with a question, just like someone doesn't come up to you and say, hey, just write a program to do it. But everyone every day comes, thanks, Steve. It's really learning can answer well. That are good, that you can do, it's more cheap. The question is how, like you want to predict. You want to know if it's weird. And learning, supervised, right? And this is like weird. And then when you put it like that, then it's easy. But that's the process, right? Because just you have no data, you have no machine learning. Okay, you need to have lemons and you're squeezing them. No lemons and you want to make lemonade. That's a problem. You have rock. Try to make lemonade. Tastes very good. I mean, I guess it depends on if there were rocks from here. Because this seems like a really clean country. You know? We may need to take this offline. Okay, all right. Data, because for those of you that work at bank, there's a lot of garbage in your data, right? That's why they're the data janitors of the computer science area. Yep. Then after that, the majority of the time is here. Garbage. More. You got to separate data into a trace. Here you train, test it with the dev set, and you loop here, and then when you're you have a problem. Another, you're noticing that it's getting really good, and then all of a sudden it sucks. You have a learning problem. Right? There's a bunch of a horse. How good these things are doing is important. If it's not sure, what should it do? Go see a doctor. It's not sure, right? So there's other measures, like when it comes to truth, how good are we at predicting it? That's called recall. The next one is when we guess truth, how accurate are we? That's precision. You see that? Those are different things. And so, and by the way, if you go to Wikipedia and type in confusion matrix, obviously Chrome will crash for a second, and then you bring it back up. There's terms for all of these, right? But these are the ones that we focus on in machine learning. There's other ones too. Like for example, like this one, I don't remember what it's called. Let's call it Thor, just because he's a good Avenger. So I'll start with this one because it's easy. Numbers, I know it's stupid, but I want you to actually see, I want you to see inside of a neural network. Okay, I'm going to show you inside it. Have you all looked inside of neural networks before? Once you see inside, your life will change. That wasn't that funny. What's wrong with you?
I'm just really tired.
Oh,
so
got
it's
it.
funnier.
Okay, so I want you to squint into the matrix and tell me what number is that. Rhymes with snive. Starts with a F. Any guesses?
5.
Good job. Good job. Yeah, so this is just a 28 by 28 matrix that has numbers in it to represent the intensity of the pixel value. Right? So this is the pixel font. So if you go back, that's that one up here. Do you see that? 5. Don't look too hard. You don't want to get trapped in the So that's what you have to give machine learning at. Only numbers. You cannot give these things like text. Like they have no feelings. These things are dumb. And I was in a panel with marketing guy Steve and some other marketing guy from other companies, which I will not name. And we were at like an educational conference, and they were all going on about how AI starts to think. And I was like, sorry, Steve, but humans are weird. We can put a smiley face on a rock, and you would think, oh, it's happy. It's a rock. These things don't think. They have no feelings. They have no, you know it's true, right? You have rocks at home with smiley faces on them, don't you? I knew it. We really wanted this, right? That's what we want. We want an int-get digit from the picture. That's what you want. In machine learning terms, we are basically going to build a function that takes a thing and outputs a thing. Right? That's what we do. Now the question is, well, what does this look like, right? And what does this look like? This is easy because it's that matrix thing. This is harder because we don't know. Now here's the thing. I don't know why that slide is there. Let me show you a thing to help you out. Oh, this is a thing. I did want to show you this. So we know what the x is, right? It's basically this thing right here. That's x. That's the thing coming in, and it's a bunch of numbers, and it's the same size every time. Now I want to know what the h looks like, and I'll give you an example. Okay, so I'm going to do a really dumb example. Do not use machine learning for this. We're just going to do it as a thought exercise. Okay. So here is a 9-square problem. Really stupid problem. You have 9 pixels, and you want to write a machine learning algorithm to predict whether it's darker at the top or darker at the bottom. Okay? It's dumb. Don't use machine learning, but I want to motivate a thing to do another thing for the other thing so you know what's going on. Okay? So over here, hold on, let's see if I can use this. So this represents the 9 pixel intensities of the first one over here. Is it darker at the top or darker at the bottom? Yeah, darker at the top. How do you know? Did you look at the numbers? Look at the numbers. These are the top 3 pixels, middle pixels, last 3 pixels. So if you were to write it up, and you could go ahead and use your programmer lizard brain, how would you write this algorithm so that if you were given these 9 pixel values, you would guess whether it's darker at the top or darker? What would you do? Sum. Oh, it's just sum of what?
Sum of the numbers.
Of which ones?
All from the top.
So top 3 sum,
Yep.
bottom 3 sum,
Yep.
and compare.
Yep.
Nice. So this country is a lot smarter than many of the countries I go to because they're always like, you should take the average of both. And all of you are like, ha! That's why in America they call it math, not maths. Like everywhere, is it maths here? Like you have plural maths. In America we have, oh, you only have 1 too? Who's from the UK? They have like 2 or something. It's maths, right? With its, I don't know what extra they have. But anyway, basically taking the average of both is the same as adding them, and you can take the divide by 3 out of both sides and it still works, right? So add the top 3, add the bottom 3. Okay, now I'm going to force you to do something that's going to be a little bit uncomfortable, but does not violate the code of conduct. Sorry, I'm tired. I'm going to force you to put it into this. Now imagine you have the 9 pixels coming in here, and I'm going to ask you to pick some magic W's such that when you multiply each of these numbers together and you add them, you still get the right answer. What numbers would those be?
Together should be 1.
Okay, so the first 3, if they're 1s here, you're multiplying these by 1 and you're adding them together, right? Which is what we want. Good, absolutely. But what should the other W's be?
-1.
Where?
-1, right?
Where? Here?
No,
The last one. Because when you do -1s here, you're basically adding these together and making them negative. What do we do with the middle ones?
Zeros.
Boom! So now what you've done, see, this is why this is really smart country, right? You basically are adding these, take the 1 out in front, and you're subtracting them, basically, the sum of them. And if it's more strong over here, the answer is going to be negative, you guess. If the answer is positive, you guess. Any questions? That was a trick question. There has to be a question. Nobody asked me what that B was. Shame on you, all of you. No, this is another number you just add in. You pick a B. What B would you pick to make this work?
0.
0. But listen, what if you wanted to make it such that the top is not darker than the bottom, but if it's close enough, we still want to guess top? Then you add a positive number and it biases it towards the top, right? If you want to guess bottom more often, right, if it's within a certain couple of things, you add a negative number and it biases it towards the bottom. In machine learning, this is called the bias. It's true. Yeah. So basically, you people just made a machine learning model. Let me show you. These numbers go in, these numbers come out. At the bottom, you see 236, you guess top. Same thing with negative on the bottom, right? You see negative 234, you guess bottom. That thing, that W and that B is a machine learning model. And that thing you made is a prediction. That's it. All of you are saying this is not machine, this can't be machine learning. This is basically logistic regression. Who's like the real data scientist out there? Not me, but like a real one. That's basically logistic regression, more or less. It's just that you add a sigmoid on the outside and the cost function's different.
Somewhere between 0 and 1.
+1 and -1 in this case. This is basically logistic regression, and you just made it up in your head. You're probably thinking, but I thought deep learning was new. No, this is the foundation of deep learning, and this thing was invented in 1954 by Frank Rosenblatt. Turns out that AI has gone through several winters from the beginning of time. In fact, when I went to grad school, we were in our deep AI, we were in our neural network winter, our 3rd one, and I thought they were stupid because mathematically they weren't as nice. Okay, so you're probably thinking, great, I don't believe this. What if I wanted to guess top, middle, and bottom, Seth? How would you do that? Well, you just make 3 of them, right? And then you put them together like this, right? There's this number. And then you take this thing like we did before. Remember that little tree thing where we multiplied by the numbers and then added them together? So you take this thing, you turn on its side, and you go num, 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 and then out come numbers. This is basically the Cookie Monster operator. And out come these numbers. And which one is the right answer? Max index. Do you see that?
Middle one.
Is this the highest number? This is why we only have one math in this country, I think. Because in America, this one's bigger. Right, this thing that you figured out, this W, and I omitted a B, by the way, you would have a B with 3 numbers in it too. The bias, I just left it out. This thing is the basic unit of all neural networks. Did you know that? This is now a new machine learning thing. The thing comes in and guesses top, middle, bottom. The same thing. With that number thing, you do the same thing. Like with this one, these are what the features look like. This is what the output looks like. And now it's, instead of this, it's something a little bit bigger like this. Doing this model and optimizing it in the standard way will get you almost 92% accuracy. and this is stupid. How do we get all the W's and B's though, right? Are you gonna go and like guess them, you know? We're gonna guess them all uniformly at random until the thing works, right? How do you guess all these numbers? Well, I'm gonna show you some stuff, and I gotta look at my clock because I don't wanna run out of time. Oh, good, I'm doing great. What time is this done? 10 o'clock? How do you guess these numbers, right? There's a lot of them. Did you say 11? No.
Definitely not.
Oh. I know, that's too soon, right? Well, we want to minimize mistakes. And so what we're going to do is we're going to use some maths, like the UK kind, like the extra bits of math. And I'm going to make a function that looks scary, but when I show it to you, you'll be scared at first, but just like when you jump in the cold pool, you're like, and then you swim around, it's okay. You're like, oh, this is good. I feel this now. This is great. So this is our function that guesses stuff, right? This is our function. This is the thing that's the right answer. Because remember, we have to give it the answers and the data. Remember that? The input and the answer. So here is the input. Here is the answer. When we get the right answer, if we guess the number 0 and the right answer is 0, what does this equal?
0.
If we get anything other than the right answer, what does this equal? Not 0. And then we square it. To make it even worse. we want to really penalize this when you get the wrong answer. This is called the Sucky function. How sucky is our machine learning model function? The data scientists call it the cost function, but it's not as cool. Or the loss function, too. For those of you that are data scientists, mean squared error. Right, this measures how bad we are at it. And what we want to do is we want to find the parameters W and B such that this is as low as possible. How do we do that? Well, there's a square over there, so it kind of looks like x squared, so I will draw x squared because that's what we got to do. You see the square over there? So this is basically the same as this, right? Squint, you'll see it. Right, x squared. How do you know where the minimum of that function is? Where is the lowest value of y? 0. How do you know? Because you looked at it. I got it. But let's pretend you're blind and you're just sitting up there like 2D Super Mario. How do you know if you're at the bottom of that thing? Blind Super Mario. How do you know?
Let's start walking.
Start walking. And if you're walking and you're going down, you're going in the right direction, right? If you're walking and you're going up, it's a problem. But what if you want to make a decision at that point in time? Well, Super Mario obviously is going to put his foot forward and be like, ooh, down. And his foot back and be like, ooh, up. And he's going to measure this tiny triangle. Let's just call it dy and dx because we want to. And then what we're going to do is we're going to divide them, right? And then we're going to make these little tiny slices go infinitely to 0 because we can do that. And then that will tell you what the slope is at that point, right? Congratulations, this is calculus. Good job, that's all it was. I don't know why they made it harder than this. The derivative of this function tells you the slope at every point. The derivative of x squared, can anyone guess? Don't look over there, I can't reach. Do you want to know how I remember this? It's so stupid. So it's like when you take the derivative of a polynomial, the person upstairs moves to the downstairs, and they're so sad that they lose a person, they subtract 1. What's the derivative of x cubed?
2 times x.
3x squared, because the 3 moved down, and they were so sad they lost a person at the top. It's crazy, right? It's stupid. But I remember that forever the rest of my life. And then the other ones you just have to memorize, not as fun. So basically, everywhere at this point, you know the slope of this function, right? So if you're at x equals 3, right, the value of the function is x squared 9, right? What's the value of the derivative? 6, positive 6, right? At 3, so 2 times 3 is 6. So, if we know that the slope is 6, which way do we want to go? Negative or positive? Well, if we're right here, do we want to walk in the negative direction to get to the bottom or positive? Kind of laying them out there for you, okay? It's a lot. I know it's... We want to go left. So what we do is we subtract the value of the derivative. So what is 3 minus 6? Minus 3. Okay, good. Okay, we went in the right direction, but we had a problem. What's the derivative of minus 3? Well, 2 times a negative 3 is a negative 6. And we're at negative 3 and we subtract a negative 6, it's basically 6 minus 3 because there's no such thing as subtraction, only addition of negative numbers. That saved my 4th grade. By the way, there's no such thing as subtraction, only addition of negative numbers. So I put a plus on every single minus and put a little negative next to the other number. That's how I passed 4th grade the second time. So basically, now that you're here, right? Minus 3 minus a minus 6, that's like 6 minus 3. It puts you back over here at 3 and you're bouncing around forever. That's not good. So what you do is you subtract off a fraction of the derivative. So if we take half of the derivative, if I'm at 3, and then I say I'm going to subtract half of 2 times 3, right? That means that when I'm here, the derivative is 6. If I take half of 6, it's 3. If I subtract 3 from 3, it puts me in the exact right spot, right? That fraction is called the learning rate, and that is called stochastic gradient descent. And that's the workhorse of all deep learning algorithms. That's stupid, huh? If you've heard of an atom optimizer or an RMS prof, it's a variant of stochastic gradient descent. Stochastic means that you give it batches of data, your initial W's, and you subtract off a fraction of the gradient of the cost function. And you do this in a for loop for as long as it takes. And that's how that works. By the way, if you're interested, I know there is an arithmetic error with my calculus, and I apologize. For those of you that found it, I'm sorry. The 2 did not graduate like he was supposed to. So this should be a 2, right? But this is the function for the derivative of the cost function with respect to W, and this is it with respect to B. And so basically, if you're looking at this stuff, right, in NumPy, we load it up here. Doesn't that sound like a really cool keyboard, right?
Sounds like IBM.
You like this crap? Look at this. I bring my own keyboard because I'm really nerdy. So basically, this square thing that I showed you before, if you want to look at what this code looks like in Python, you can see that, well, this is, I don't want to do this one. This one's too complicated. Let me do a triple here. This is the one I wanted to do. Notice that when I'm training it, I'm basically doing a for loop over that thing that I just did. Well, there's the loss function, the square of h minus y mean, right? This is the accuracy. Remember, this looks weird, but I want the max index for the answer, not the number. This tells me how accurate I am. And then I print this out, and notice that when I update it, the gradient is that formula I said, and then I subtract off the learning rate times the gradient. This is basically it. If I run this, this is with the triples, right? If I run all of this, let me see if I can, it should be super fast, right? There it is. There it's drawing. This is still running. No, that finished already. This is the final, this is it's training it right now in the loop. I literally wrote that thing that I just showed you. It's looping through now. The loss is going down. The accuracy is going up. Do you see that? And then if I scroll all the way down, the final W for this one is not what we had before. Remember how I had 1s and 0s? But basically, this is mathematically equivalent. Right? This forces all of the ones on this side to go negative and sums the top 3. That's crazy, right? I basically wrote that thing that I showed you in how many lines of Python? Oh, whoops. Well, scary. How many lines of Python? Like 10?
You almost got taken by the matrix.
Yeah, that was crazy. I almost got eaten. Now let's do a prediction of this one. Boom, top. Well, let's do this. Let's make this 255. 255. Oh, that's too much. I don't want to blow it up, right? I mean, do you see it guessing? That was stupid, right? Basically, machine learning with deep learning is now stacking those things on top of each other. And then doing other crazy things called regularization to make sure that you're getting the right values, right? And then also doing some crazy things with pictures like convolutions, right? Or if you're using text, putting them in sequences. So that's the basic unit of all deep learning in a nutshell, right? And did I use any crazy machine learning frameworks to do that? I did not, because that's stupid. The more complicated ones are obviously more stupid, and so you have to use something a little more
What would be
complicated.
the prediction if you would put 255 on the top, on that example?
Oh, this one?
Yeah. And if you run it again?
By the way,
But that's because of the B, right?
there is no B. I don't think, oh yeah, probably because of the B. But here's the thing, this is what, I was like, oh, I did hit the B. I really thought of myself in the past. Past Seth was really nice to future Seth. I was like, no, I'm too stupid to do that. Oh wait, there it is, thank you. Yeah, so you're looking at this and you're like, this isn't exact, Seth. Yeah. That's machine learning. Right? And you're wondering, well, how do you get these numbers? I told you, there's a little Mario running around in that for loop trying to find where the bottom of that thing is. And then he found one that's close enough, right? And you can see that that's what it is. Now you're probably wondering, well, what the heck? It gets top even though they're all, like what if I put 255 in all of them? What's going to happen then? Sorry, just kidding. No, that's not it. Right? It just gets top. Do I know why? No, I don't know. I mean, I guess I could go in there and look at the numbers. But the problem is that when you have a deep neural network, this matrix here, specifically when it comes to digits, is going to be 784 wide. How do you make sense of that? And that's the problem, I think, with deep learning. There's no computational learning theory behind it, which is okay, I guess. But. All right, so we learned how the things work. We did that thing. Did I go back all of a sudden? Oh, now what you can do is you can stack them, put functions in between them. By the way, if you just stack them the way I showed you, that's not neural networks. It's basically linear combinations of linear combinations are still linear combinations. You can prove that inductively. So you add a function in between called activation functions, and now these things are neural networks. Okay. All right, are we good with this? Now you know. Now the process of figuring all this stuff out is you have to choose the right architecture of neural network. You have to choose the right cost function. I showed you mean squared error, but there's others, right? Like binary cross entropy, a bunch of other ones. And then you have to choose, so it's the right model function, the right cost function, and then the right optimizer. Like the SGD that I showed you, stochastic gradient descent, that works sometimes, but others are better, like Atom or RMS prop or other. So how do you know which ones to use for your data?
Science.
You use science. Thank you, sir. And as you know, science is a fancy way of saying, we're going to guess and see if it works. That's science, right? And that's why it's called data science. Okay? All right, so I did that. Let's talk about Azure Machine Learning Service, because now I want to get into the new stuff. So,
Seth, it's 8:31.
oh, am I over? Is it over?
I think it's done at 8:30.
Oh, shoot. Can I show you like one thing?
You can do it. I will allow it.
She's really in charge. It's not even,
We do.
it's not even true. It's not even.
One thing.
Here is the new workspace. You saw the cool automated ML things. Now you can keep track of all of your data sets, experiments, models, and endpoints. You can have shared compute, data stores, and node VMs. So as you do your sciencing, you can actually output stuff and see what people did over the lifespan of all your machine learning among all of your coworkers. Right? Because this kind of sciencing takes a long time, and if you have a super good data scientist like Sally, obviously Sally's going to get a new job, not at the bank, somewhere else. make tons of money. But then what do you do when the new data scientists come in and Sally had all her stuff on her hard drive that was wiped? That's why you do everything together.
You got the
That's how-
mailbox still.
What's that?
You got the mailbox.
Oh, yes. Yeah, you
That's
do.
a backup, right?
And so that's the Azure Machine Learning Service. For those that are wondering, you want to take 2 minutes and then we'll close. Because some of you are asking about this thing, right? This is still in there.
Yeah, so someone was asking about the old ML Studio. So it's still there, but it's now called Visual Interface. So we're redoing it. It's now integrated into the Azure Machine Learning Service that he was talking about. All right, Mike's. So what it is, for those that don't know, it's a visual interface that allows you to build machine learning models with this graphical UI. It kind of looks like a Visio diagram. And just give you a quick little tour of it. So someone was asking about data sets. There's a bunch of sample data sets that are already loaded into this. So if you spin up an Azure Machine Learning Service and you go into Visual Interface, you can come in here and just start playing with some sample data sets. And then if you go in here, you can see the different models that are available within it. You can do custom code within it. So if you want to use Python or R, you can execute that within it and do anything. If you want to use the pre-built functions, you can't do everything, but you can do a lot of like the basic solved questions that Seth was talking about. So this is just a basic model where we're doing some time series forecasting to predict demand for a particular item for a store, so retail sales forecasting. It's a regression, so it's predicting a number. I won't go into too much detail since we're over time. Does anybody have any questions about visual interface or, yeah?
Can you also do automatic machine learning?
Auto machine learning? No, you would want to use the one that she
Okay.
showed.
Not
for
any
that.
visual interface.
Yeah.
Okay.
So this one is visual interface, that one's AutoML.
Yeah.
They're both graphical or I guess I would kind of say like no code, even though you can use code in visual interface. But they're both kind of graphical UIs to build models.
Yeah, so that's one way of doing it. Another way of doing it is actually, for example, and hopefully this loads up fast because it was slow earlier today. Basically, this is an example of me running that digits thing that I was showing you, but inside of Azure Machine Learning Service. Well, it might take a while. So I'll let it load up, and then you can see it a little bit later. Okay, so I believe I am out of time unless anyone has any questions. Explainable AI, unfortunately, I don't have time for, but I can show you. There's gonna be a video coming out about it, like next week or the week after. I'm not sure. Thank you so much. Hopefully this was helpful, and now you get a good sense for what's going on inside of these things. They're not magical. Like, if you want, later I can open a file and show you. Basically, those things are in there, the numbers, B's and W's. It's really not as mysterious as everyone thinks. And it's rather unfortunate that it's gotten to the point where people are like, well, like for example, and I feel bad, but take a look at this little thing. So I'm gonna reveal this in Explorer, and I'm gonna open an actual model file that this thing made. Are you ready? Like, this is the actual model that it output. And when you look at it, like I just had a 2-stack, and notice that there's the kernel. It's that matrix I told you about. Look at the size. And look, these are the numbers that it learned. Like, I don't know what else to say, but it basically learned more numbers on its own. That's a model.
Did you have a question?
Yes?
So your conclusion is that the visual interface is going to replace the Azure Machine Learning Studio.
Yes,
So
it
the
is.
studio will disappear in the future.
Eventually, yeah.
Okay.
Yep, and then it's in preview now, so we're still working on the visual interface, but yeah, eventually, Reunion Studio will be able to do a visual interface.
But all in the same place.
Yeah, it's
Okay.
really nice now that it's integrated into visual interface or that it's integrated into the service because the models and the experiments all are showing up in the back end. So if you're building with AutoML, you can share data sets as well. So the data set stuff she was showing, you could use that same data set in visual interface or in AutoML or in a custom experiment. So it's now all kind of integrated together into a
So the pipeline we supposed to use for the older Azure Machine Learning Studio, we still can use in the
Yes.
interface.
Yes.
Everything stays the same, even
We will do the best we can to make it stay the same, yes.
How about the Azure Machine Learning Workbench?
That has now been integrated into Azure Machine Learning Service altogether.
It's not integrated.
It is. If you looked at the data set stuff that she did, you saw some of the workbench features in there. Yeah, you, like the little, you saw the little, like when you loaded up the data, you saw all the histograms and stuff. That's kind of cool. But we'll talk afterwards. I want to make sure if people need to go, you can go. Thank you so much for your time. We really appreciate it.